In order to build robust control charts, we need to talk about one more topic, and that is homogeneity. Two samples are considered to be homogeneous if they are drawn from the same underlying distribution. In order for our control charts to be valid, the rule is that all of the things that we are grouping together must be homogeneous. So in this example, I have some data that we've gathered every hour, and I have grouped it together, the first 8 hours being the first shift, and the second 8 hours being the second shift, and so on. So in order for this to be a valid grouping, the rule is that the underlying distribution of each of these different things that we're grouping together have to be homogeneous. So what that means is the underlying distribution of things that happen in the first hour of a shift has to be homogeneous with the underlying distribution of the things that happen in the second hour of the shift, and so on and so forth. So basically, in order for us to group by hour, all of the hours have to be homogeneous. So in order to show why this matters, I've modified the data so that the data in the first hour has an extra 10 added to it when I pull it from the raw data into the grouping. So each one of these has the extra 10 in it. The net effect of this is that the first hour's underlying distribution is not the same as the second hour's underlying distribution or any of the other hours' underlying distribution. So the data for the first hour is not homogeneous with the rest of the data in the system. So let's compare what has happened. In this not homogeneous tab, I have the exact same data that I have in the in control tab, except that I have added 10 to the things that happen in the first hour of every shift. The net effect of that on range is pretty small. If you look at these range values, they're in the high 70s and low 80s. And in control, they're in the high 70s and maybe not quite the 80s, but they haven't been moved significantly. The much more significant difference is in the range. In the original data, the range is generally below 15, probably averages around 12 or so. There are some that are really high and some that are really low, but the average is smaller. In the non-homogeneous, the range values look much bigger. We have them up in the 20s. And if we look, the average range in the not homogeneous is 18.6, where the average range in the homogeneous is 13.9. That's a pretty big difference. So in the original data, the average range was about 14, and that gave us range limits that went from 4 to 28.5. So the action limits on the range chart were about 4 and about 28.5. In the non-homogeneous state, the range limits now go from 5 to 38. So the distance between the two action limits is much bigger in the non-homogeneous case because the average range was bigger. Similarly, if we look at the distance between the action limits in the average chart, the original action limits were 72.5 and 82.75. But in the non-homogeneous case, the action limits are 71 and 85.75. So they are, again, significantly further apart, which means that because the data was not homogeneous, things are going to look like they're in control when they're really out of control. And so the lack of homogeneity makes the control charts not sensitive.